potential and kinetic energy. We have our measuring tape, our little plastic cup, which is going to be the edge of the cup is going to be lined up with the tile, which is lined up with the measuring tape. I have a makeshift slingshot, a pencil. When the cup moves, I'll use the pencil as a marker. And then we're going to do it again with a different amount of potential energy, which could put it here. As long as this cup is before or after the pencil, we'll be able to tell the different effects of different amounts of potential energy. So that's the point of that, and kinetic energy as well. And I'm going to be using this marker, Sharpie, that has markings on here. So the first time I am going to pull it back, I'm going to use this, and I'm going to pull it all the way behind the wooden sticks. And then the second time I'll probably pull it halfway. And the way I'll measure that is per the markings on the marker. I'll do the entire marker, and then I'll do it till the end of the writings that say Sharpie. And we'll see which pullback spring force gets the greater distance in hitting this. So I'm also going to place this guy right on the markings of the tile, so we know we have the same distance when we're doing the pullback, creating the potential energy, if you will. So we'll be able to measure how far along we've gone. So I hope that makes sense. Anyway, so we're gonna, again, line up the rim, but on the other side by me, this side of the tile. We have 1 to 12 here. This is just gonna be our marker. And again, this is gonna go into another groove 12 inches away each time. So we have the same, approximately the same variables when we do this. So the first time I'm gonna pull the marker all the way back. And this went boop, right there. I feel like that should have went further, but it didn't. That's 3.5 inches. And now we're gonna do this again, same direction of the marker. And I'm only gonna pull it halfway back, which is to the end of the word Sharpie. Problems. So we're gonna do it again. Even though I know that was 3.5, we're just gonna do it again because I didn't like the first one anyway. That's science, y'all. Trial and error, right? So again, I'm gonna pull this guy back all the way to the end. And there we go. Whew, that was much better. And I'm gonna put this guy, boop, which is just past 12, because it's not quite on the line. So that's 12.5. Right back to the beginning. And this time we're gonna go halfway, which is again, this first time I pulled it all the way back the length of the marker. And this time I'm only gonna pull it back half the length of the marker where it stops. There. Let's try that again. See what we get. Oh, boom, perfect. Clearly you can see that with the full length of the marker pulled back, there was a greater potential energy, and its kinetic energy was able to do work in pushing the cup all the way the distance to the pencil. When I did half the distance of half the length of the marker, creating less potential energy, it resulted in a lesser amount of kinetic energy, only moving the cup up to here, which is not as far as the pencil. If you want the measurement, it's about 3.5. So the greater potential energy created 12.5 inches. The lesser potential energy created 4.5 inches of kinetic energy, which is what I just showed you here. That's what we did. Thanks.